In this video, I'm going to show you how to train a UNet classifier to segment epithelium and stroma. So in the previous video, we defined the data. So if we go in datasets in UNet and epithelium stroma, now we have training and validation, two folders that both contain images and mask, where mask correspond to the annotation for epithelium, stroma, and background for these images. So I'm gonna now first load my virtual environment and then train the UNet. So I'm gonna open a command prompt. And the first thing I need to do is to go to activate my virtual environment, and it's actually in this folder. It corresponds to a folder I downloaded from GitHub. And to activate it, I'm going in the name of the virtual environment in Windows, and then in scripts and activate. And that's going to activate my virtual environment. Now I have the name of the virtual environment in front of my line. And so now I can type in Jupyter Notebook, which opens a web browser. And it puts me in the location where I was in the command prompt, which is inside the folder I downloaded from GitHub. So I'm going to go into codes and UNet. And as you can see, we have two folders, the one with datasets, one with train classifiers. So that's where we're going to save the classifiers we're going to train. We have 3 notebooks for pre-processing, one for running UNet and one for training UNet, and finally 2 Python files with all the codes we need to train and process UNets. So I'm going to open the training notebook, and it looks like all the notebooks we're going to use in this workshop, where we have text panel. So the first one, it actually describes what the next code panel is going to do. So it's loading, so I can run this. It doesn't do anything because it's just text, but if I run it, I go to the next panel, and this one I need to run it, so I'm going to hit run, and it actually loads all the codes and all the Python libraries we need for training UNet. The next panel is this one, where we're going to define all the parameters for the training. So let's go through each parameters. The first one is the training directory. So by default, I'm in datasets in UNet. So I'm going to go into epithelium stroma, and that's where we have the 2 folders we defined. So the one we want here is training. I'm going to select training. And now I'm in the correct location, so I can just select this one. So just as a note here, it works fine sometimes, and most of the time with Mac OS. When you select it, then you have a blank space here. Just click on the blank space, and then you should have something like this. So I'm going to now go to the next parameter. Second parameter is the validation directory. So in datasets, epithelium stroma, I'm going to select validation, and that's the correct folder. And finally, the output, where I want to save my classifiers. So by default, when I hit select, I'm in train classifiers. I'm going to select epithelium stroma, and that's where I will save the train classifier. Now we have a few other parameters. So first, how many channels are we using? So we use DAPI and cytokeratin. So we have 2 channels, so I'm going to change it. I can use the arrow here, or I could type in here. It works as well. Then I need to define the number of classes. So we have background, epithelium, and stroma. So we have 3 classes, so that's already correct. Then we can define the imaging field. So that's the size that is considered by the training by UNet. So here it's 256 by 256. So as we have much larger images, they are about 1800, 1400. If we keep it that way, for each image, there's going to be a random crop of an image patch of size 256 by 256 in the original image. And for each epoch, it's going to be a different crop. For each image, it's going to be a different crop. So that's actually what we're going to use. We could increase the size, and it doesn't have to be a square. It could be different dimensions for X and Y. We're going to keep it that way, so even with GPU that are not that powerful, it's going to work. For learning rate, we saw that this is a very critical parameter, so for now I'm going to keep this value and we'll see what we get. Then the number of epochs, I'm going to keep it 200, 100. UNet is pretty fast, so we need to define a number of epochs that is large enough so we have a convergence of the training, so I'm going to keep it to 100. Data augmentation, I'm not going to do it for now, we'll see that later on. The batch size corresponds to the number of images that are processed at once. If you have a very powerful GPU, you can process several images at once, even if you have larger imaging field, but here I'm going to keep it to 1. The last parameter is the proportion of images that are used in validation if you only define a training directory. But here we have a training and a validation directory, so this is not going to be taken into account. So all my parameters are defined. I'm now going to train a UNet, so I go to the next code panel and I'm going to hit run. So it starts with a bunch of warnings. But don't worry, it's normal. It's just because we use different versions of different packages, and there are some warnings to let us know that we won't be able to use the same codes in future versions. But for now, it's fine. So you can just keep it the way it is. Then you have a number of images. So we have 10 training images and 4 validation images. And then you have the epoch. So you see it already started. It's pretty fast. It just takes 1 second per epoch. And so we have all this variable information: loss, accuracy, validation, loss, and validation accuracy, the time it takes for each epoch, for each step, and here the epoch number. But we don't need to look at this way because we're going to use TensorBoard to visualize all this value. So we're just going to wait for it to be done. You know, it's almost done, just 20 seconds, and we'll be ready. So you can use this to reduce the size of it. So I'm going to just put it like this. I know that it's still running because I have a star here. I also have this icon on top that tells me that it's running for now, and you see now it's down. I have a notebook here, so that means that this is over. I can just go back to it and see, and you see the 100th epoch is down. So I'm just going to reduce it again, and I'm going to open TensorBoard now. The first time you run it, most of the time it's just waiting, and if you wait enough, it's going to tell you that it takes too much time and it's not running. Just stop it and run it again. So I don't know what does that, to be honest, but that does the trick. All right, and now you see we have TensorBoard, so we can visualize the accuracy for training. This is the loss for training. And then we have the loss for the validation dataset, for example. So we see that the loss decreases over the epochs. And for validation, it also decreases and then increases. Now, it's going to be a good idea to just run it with several values for the learning rate, so we can know if this learning rate is a good value or not. So I'm going to go back up. And here you can see that you can define a parameter that's going to let you batch process. So here it's 1, so it's just 1 training. But let's say we want to do 3 trainings with different parameters. So I can change this value to 3, and now I can run it. And if you look at it, now you have one set of parameters here, a second set of parameters here, and a third set of parameters, okay? So I'm going to run the same thing. So I'm going to do the exact same training, but I'm going to change, the value of the learning rate. So if I go back here, training directory is still the same, epithelium stroma training, select. Epithelium stroma validation, select, and finally train classifier in epithelium stroma. Now you can see that one classifier has been trained here, and the name of this classifier is actually a unit that is followed by the different parameters we define here. So 2 channels, 3 classes, 256 by 256 with a learning rate of 0.0001. No data augmentation, 100 epochs. Okay, so that was the one we just trained. Here we're in the right folder. I'm going to select this folder and I'm going to change the parameters. So we have 2 channels. Everything else is good. I told you I want to change the learning rate. So I'm going to start with a high learning rate, 1. And let's define a different set of parameters. Epithelium stroma training, epithelium stroma validation, epithelium stroma here. All right, 2 channels, and this time I'm going to take a learning rate of 0.01, and last set of parameters, epithelium stroma training, epithelium stroma validation, and finally epithelium stroma in train classifiers, 2 channel. This is the value I took for the first training, so I'm going to take something that is 100 times less. So now we have 0.01, the one we did before, 1e minus 4, and this one 1e minus 6. So I'm going to train all of this, all right. And all right, it started. And now what I'm going to do is I'm going to speed up the video so you don't have to wait for it, but we should see the curves that are defined over the training. All right, it's done. So as you can see, we have 4 different curves. When we look at the validation on the at the loss on the training and on the validation, what we see is that the orange and dark red curves, which corresponds to a learning rate of 1e minus 4 or 0.01, converge much better than the 2 other curves. So the light blue is a learning rate of 1e minus 6. So clearly here it's too low, and we have an underfitting that is going on because the optimization doesn't really converge, way too slowly. If we look at the validation, it slowly decreases, but very slowly, and not enough for sure, especially when you compare with the other ones. For the learning rate equal to 1, the dark blue curves, it's clearly too high, and here we don't converge at all. And when you look at the validation, it's constant, meaning most probably all pixels are labeled as being part of a background, for example, or at least they are all labeled as being part of one class. So looking at the validation loss, or the loss, is interesting. It might be easier to interpret if we look at the accuracy actually. So let's have a look at the accuracy here. And so it's similar. We see that the dark blue curve is not increasing, it's really low. The light blue curve increases a little bit, but it's clearly not satisfying. When we look at the 2 other curves, they actually have very similar results, and they end up about 0.9, both of them. If we look at the accuracy on the validation data set, it's very similar. Again, interestingly, it seems that the learning rate of 0.01 doesn't give the accuracy you can get for learning rate of 0.0001. So there's quite some difference. At the end, we're about 0.9 with 1e minus 4, 0.85 for the other one. So it seems that this is the best value. Now, before processing these units and see what kind of results we can get, we're going to try one last thing, which is to do some data augmentation. So I'm going to go back to the parameterization, but I'm just going to do one training this time. So I'm going to define, go back to 1 for the number of trainings, run this panel, and I'm going to define one set of parameters. So this doesn't change. It's still epithelium stroma training. All right, epithelium stroma validation, perfect. And I want to define an epithelium stroma, so I can see the 4 classifiers that were already defined. I still have 2 channel, 3 classes. I'm not going to change the imaging field. I'm going to use a learning rate of 1 E-4 because so far that's the best value I got. I could try to find a better value for the learning rates based on this training parameters, but I'm going to just use this one. And now I'm going to do an augmentation. So let's say I'm going to do 10 augmentation. So it means for each image I have in the training data set, I'm going to apply mathematical transformation to this image 10 times. So I'm going to get 10 over image where I change the amount of noise that is added, where I can flip, rotate, can change the brightness, etc. So as I have more images, so instead of doing just 14 images in the training data sets, now I'm going to have 14 plus 10 times 14. No, I have 10 images in training dataset, 4 in validation. So instead of 10, I'm going to have 10 plus 10 times number of augmentation 10. So I'm going to have 110 images in the training dataset. So I'm not going to do 100 epochs. I'm going to reduce it to 25. Let's see what we get. So these are my new parameters. Now I'm going to train it. And again, I'm going to speed up the video so you don't have to wait for the entire training, and we should see it going interactively as well. All right, it's down. So if we look at the results, so it corresponds to the magenta curve. Clearly, the accuracy on the training dataset is higher, so it converges faster, which is not a surprise because we use much more data. So it's not surprising that it converges faster than when we don't do data augmentation. But even with that, we end up with something around 0.95, which is definitely better than what we had before, around 0.9. If we look at the validation data set, the accuracy is also higher, and we end up with something around 0.95, so very similar to what we have, even a little bit better, 0.96, so something similar to what we have in the training data set. So that's pretty good. So it seems that there's no overfitting in there. So that's probably is going to be the the most interesting result. So that's the classifier we'll use in the following. And just to final note, it took about 8 minutes and 33 seconds to be correct. So it's still pretty fast to do. So before leaving, I just want to show you a few things. First of all, when you're done, if you're training, you can close the tab. Don't forget to shut down the process. So to do so, you just check the box which is in front of training. So you see the notebook is in green. So it means that it's actually running. You see, it's there. It shows running. So I'm going to check this box and then I can shut it down. So I'm going to shut it down, and now you're going to see it went back to black and white, and there's nothing in green here. So that means that it's been shut down. If you use a GPU, it's important because most of the time, so depending on GPUs you have, but it's very much likely that you're going to use the whole resource you have on your GPU to do your training, and then if you try to do a running, you're going to have a memory problem because everything is used for training. So you need to shut down your training before. The last thing, now we have a new folder which is called logs. If we go inside, we have the scalars, and inside scalars we have 5 different files with the names of the classifiers we train, followed by the date and time. So that's actually the files that are used by TensorBoard for the visualization of accuracy and loss for both training and validation data sets. These files are generated when training the unit, so they are useful, but if you do serial training, then you're going to have way too many files. So even if in TensorBoard you can select the ones you want to look at, you might want to remove them. So you can either remove them directly, or you can save them in a different folder. So if you want to go back to your values and check them for a previous training, you can put them back here and use TensorBoard in the training notebook to have a look at it again. And with that, we're going to finish this video for training. Next one is going to be how we can use the train classifiers to actually segment epithelium and stroma in real images.